Hello, we are going to do chapter 4 as far as we can get with doing some video notes to see how we go. Chapter 4 is all about vectors, and 4.1 is just kind of the beginning of vectors. So hopefully we've dealt with vectors before, and vectors can be represented by ordered pairs, ordered triples, depending on what dimensional space it is we're talking about. So just to get some basic information about vectors, so let's make sure we can add them. So the vector 1, negative 4 plus the vector 2, 5. When we add vectors, we just add the matching components. So add my 2x's, I get 3. Add my 2y's, I get 1. So we can say the vector 3, 1 is a linear combination of the vectors 1, negative 4 and 2, 5, because it is exactly what it is. I combine them in a line. So we can do this with scalar multiplication. We can do this with adding and subtracting. Those work just fine. All right, so let's do something slightly more complicated and solve an equation. So if I told you U is the vector 1, negative 1, 2, V is the vector 0, 2, 3, and W is the vector 0, 1, 1, and I gave the equation 3x plus 2u minus v plus 2w equals 0 and said solve it for x. There are multiple ways we can do this. You can plug everything in to begin with and solve from there, but I think it's easier to get x by itself. So I'm going to say x equals, subtract my 2u, so minus 2u, add v, subtract 2w, but I want x by itself, so I want to get rid of that 3 also, so I'm going to divide by it. Now I can plug it in, it's a little bit nicer. So I get x is 1/3 times negative 2 times u is going to be negative 2 to negative 4. Add that to v, which is 0, 2, 3. I'm going to add that to negative 2 times w, which is 0, negative 2, negative 2. All right, so now I'm going to get x is 1/3 times, add up the components. Add up my x's, I get negative 2. Add up my y's, 2 and 2 is 4, minus 2 is 2. Add up my z's, negative 4 and 3 is negative 1, minus 2 is negative 3. But don't forget to go ahead and multiply that by that 1/3. I want to know what the vector x is. So it's going to give me negative 2/3, comma, positive 2/3, negative 1. So x is a linear combination of u, v, and w. You can use, as I said, scalar multiplication, adding and subtracting to get it. So that's what a linear combination is. So now we need to find a linear combination. How do we get a certain combination? All right. So number 12 in the notes, I want to get v, which is 4, 4, 5, from some combination of x, y, and z. X is the vector 1, 2, 3. Y is the vector negative 2, 0, 1. And z is the vector 1, 0, 0. So that means I want something times x plus something else times y plus something else times z to give me 4, 4, 5. So it's some linear combination of x, y, and z to give me 4, 4, 5. Well, we're going to solve this using a matrix. All right, so typically, if you think back to when we solved systems back in chapter 1, if we're given equations, we put them in a matrix as rows. Well, here we're given vectors. Typically, vectors go in a matrix as columns. Not always, but typically they do. So if you remember back to our eigenvalues and eigenvectors, we put our eigenvectors in as columns to our matrix P in order to diagonalize. So that's what we're going to do here. So I'm going to create a matrix, and my x vector is going to go in first, 1, 2, 3. Next to my second column, negative 2, 0, 1 for my y's. Next to my column for my z's, 1, 0, 0. And I want to get out 4, 4, 5. So now if I can solve that matrix, I know what A, B, and C are, and I can go ahead and come up with my linear combination. All right, so typically I would go ahead, because I have a 1 in that top spot, and get zeros underneath it. You can do that, that's fine. Here I happen to notice something a little bit nicer. So I'm going to leave my top row, but I'm going to divide my second row by 2. Gives me 1, 0, 0, 2. And then I'm going to leave my bottom one, 3, 0, 3, 1, 0, 5. All right, so now that middle row is exactly what I want for my top row, so I'm going to move it up. 1, 0, 0, 2 over 1, negative 2, 1, 4 over 3105. All right, now I'm going to go ahead and do what we standard do and get zeros underneath that top one. So I'm going to leave 1002. I'm going to do my top row minus my second row. So 1 minus 1 is 0. 0 minus negative 2 is 2. 0 minus 1 is negative 1. 2 minus 4 is negative 2. And then I'm going to do 3 times the top row minus the bottom row. So 3 minus 3 is 0. It's going to give me negative 1, 0. 3 times negative 3 times 2 is negative 6 plus 5 is going to give me a negative 1. Apologize. Now, if you look at that bottom row, if I multiply by negative 1 and move it to the second row, it's exactly what I want for my second row. So I'm going to leave my top row. I'm going to do 0, 1, 0, 1 for my middle row. And then for my bottom row, I'm going to do 0, 2, negative 1, negative 2. And that should be a positive 1. I apologize because I did, so anyway, let me just make sure I get this right. If I did 3 row 1 minus row 3, so it's going to give me 3 minus 3 is 0, 1 minus 1 is going to give me negative 1, and that's going to give me 6 minus 5, which is a positive 1. All right, so now I'm good. So that's going to be a negative 1 there. All right. So now my top row and middle row are set. I need to work on my bottom row. So I'm going to leave 1, 0, 0, 2. I'm going to leave 1, 0, 0, 1, 0, negative 1. My bottom row, I'm going to do 0, 0. And let me think about this. So I'm going to do row 3 minus 2 row 2. All right. So 2 minus 2 is 0. That's going to give me a negative 1. Negative 2 plus 2 is 0. All right, so this tells me my first row there was A's. So my A is 2. My B is negative 1. My C is 0. So if we go back up to that equation up top, up here. So let me just point it out. This is what I was looking at. That's what I want to get. I now know what A, B, and C are. So I'm going to write that down at the bottom. So what we were looking for was AX plus BY plus CZ equaled 445. All right. Well, now I know A is 2 times X. X was 1, 2, 3. Plus B, which is a negative 1 times Y, which was negative 2, 0, 1, plus 0 times C, which was 1, 0, 0. That should equal 4, 4, 5. And you can check it fairly quickly. 2 times 1 is 2, plus 2 is your 4. 2 times 2 is 4, plus nothing is 4. 2 times 3 is 6, minus 1 will give me my 5. So yes, that is the correct linear combination. All right, that is everything for section 4.1.